A block of mass m is released from rest from a height h above the ground and slides along a frictionless track that may have any shape. What is the speed of the block just before it reaches the ground? Express your answer in terms of g and h. So, the important thing about this problem is that we have a frictionless track. That means that friction does not act on the block, and so no non-conservative forces are acting on the block Earth system. And so since no friction and no non-conservative forces are acting, then the total mechanical energy is conserved. And so we have that the initial mechanical energy is equal to the final total mechanical energy. And so both the initial and final total mechanical energies equal the sum of the kinetic and potential energies of this block. So initially we have the potential energy of the block plus the kinetic energy, and this is gravitational potential energy. Here, let me change the subscripts. So initial gravitational potential and initial kinetic energy, and that's equal to the final gravitational potential energy plus the final kinetic energy. So maybe we can sort of draw what this situation might look like. So it does say a frictionless track of any shape, but for now let's assume it looks something like this. So let's say that we have this block of mass m, and it gets released and slides down from this point down to that point. And this height is given by h. Now we can define the point where the gravitational potential energy is 0 to be any point. So let's define the gravitational potential energy to be 0 along this surface here. So let's say that the bottom of the track is when gravitational potential energy is 0. And we can do this because the change in potential energy is what really matters, not the absolute value itself of at the certain point. So if we choose this to be 0, so this is at y equals 0, and up here is at y equals h. So the initial gravitational potential energy, the block is originally at a height h above our chosen reference of y equals 0. So initially, the gravitational potential energy is just mg times h. And the initial kinetic energy is 0 since it's released from rest. And then when it slides down, the final gravitational potential energy will be 0 because the block will end up sliding down to this place where we define y equals 0. So the gravitational potential energy at the end will be 0. And the final kinetic energy is given by 1/2 mv squared, where v, the speed, is what we want to find. So now all we need to do is solve for this final speed here. So we can cancel out the masses and multiply both sides by 2, so that we get v squared equals 2gh, and then square root both sides to get that the speed v is equal to square root of 2gh. And that would be our final answer. And now it's also important to note that Newton's laws are also valid. So you could use F equals ma, find the acceleration, and use that to find the final speed. But the problem with that is that this says it slides along a frictionless track that may have any shape. So if we choose a sort of a linear incline like this, then we could find the acceleration, and the acceleration would be constant. So we could use our constant acceleration kinematic equations to figure out the final speed. But, however, the track may also look something like this, where it's much harder to find the acceleration curve like this. But with a situation like this, the acceleration would be changing at each moment. So it will be much harder to use F equals ma for this kind of problem. So instead, since there are no non-conservative forces acting like friction, we can easily use energy conservation to solve this problem. And for this specific problem, it turns out to be much easier than using F equals ma. And that is how you would solve this problem here.